A very good day to Dr. Rahim. My name is Ryan Gee. My metric number is 2010910446. My from group 1A. Today I would like to present about my open-ended lab 2, which I will talk about three-phase induction motor. So this purpose of this OEL is for us to understand the characteristic of a three-phase induction motor using different number of poles using a squirrel cage induction motor. Myself has chosen squirrel cage induction motor over the stator rotor induction motor. We also differentiate the relationship between the speed and the torque in the three-phase squirrel cage induction motor to differentiate the line current and the speed, and also to differentiate the reactive power and the speed in the three-phase squirrel cage induction motor using different modules of poles. So as you can see, we will be having the schematic for 2 poles, 4 poles, and 6 poles chosen. So this is my schematic that I run in my pit sim. This is the three-phase incoming voltage with the line voltage is 240, which is your terminal input voltage, and the frequency of 60 hertz. This is your wattmeter to measure the input power, your active power. Your VAR to measure your reactive power operating at 60 hertz frequency. Your line voltage red, yellow, and yellow blue, and your line current. The induction motor, this is a 4 pole example, so usually this is where we will change, and then your speed and your torque to at the end of the induction motor. Then you have your V out and your I out to measure your output power, and then your load, we will be differentiating it. So due to the time of simulation takes a long time, so actually I have already shown you an example. I will be taking from 8 second up to 10 second for the steady state. So this is your line current, your output power, your V in and your reactive power, speed and torque reading, and then your line voltages. So after simulating, you will get this data diagram, this data as shown above. So after you get the data of 2 pole, 4 pole, and 6 pole, we will actually put it in the table to see the difference. Moving on, this is the comparison chart of a squirrel cage induction motor of a speed versus a torque. So this is for 2 pole, and then as you can see, as the speed increases, the torque has also increased, but when it reaches a breakdown point or the breakdown torque point, you can see it starts to decrease as it stays at a fixed point. So this is for 4 pole and then for 6 pole. This is the comparison chart for a reactive power versus the induction motor speed. It's also same when it reaches the top at the breakdown point as I mentioned, but this is for the reactive power down to a nominal value. It also will start to decline at the end. So as speed increase, but your reactive power has come to a nominal value. This is the speed versus the line current. As your speed increase, you can see that your line current actually do decrease as well. For the torque versus speed, when it's produced by the 2 pole, when it reaches nominal of 54 newton per meter, you can see it reaches a nominal of 2562. For the 4 pole, when it reaches a nominal value of 71.747 nominal Newton per meter, it actually reached a nominal speed of 1700. So the 6 pole as well, when it reaches 1000, wow, no, 118 no, Newton per meter, actually comes to a speed of 1103. So among all, the one of the best to see among all is actually the 2 pole, because when your induction motor, the torque reaches nominal value, you still can get a better reading of nominal speed among the others. So this is a reactive power. Reactive power is one of the important where it draws the power to move the induction motor. And then as for line current, as speed increases, your rotor slip do increase and its speed decreases. So due to the reduce in the speed, so we can see that the speed between the rotor and the stator magnetic field in the machine has increased. So theoretically, when motor speed increases, the line current will decrease. So that's all for my presentation of this open-ended lab. Thank you very much and have a good day, sir.